Hey guys, my name is Trevor Sullivan and welcome back to my video channel. I know it's been a while since I've put a video out. I've got a lot of different excuses for that. Partially, I have a full-time job. Also, I have some pretty major health problems for the last almost 12 years at this point that really take me out of commission on a lot of my free time. So I don't really have a lot of free time per se to just do whatever I feel like. A lot of it I'm just kind of suffering from pretty severe chronic pain. So, that takes away from a lot of things that I would otherwise enjoy doing or productivity things that I'd like to be doing. So I apologize that that interferes with my ability to put content out. But in any case, I just kind of recently randomly came across this use case where I needed to generate some random data on the file system. And so what I did is I whipped up a really quick PowerShell script that just writes some randomized data to the file system. And I wanted to show you how you can write this in a more performant fashion using some of the available .NET types instead of using built-in PowerShell commands. Now, I want to just kind of map out what the process flow of this would look like for starters here. So in my VS Code editor here, I'll just kind of put in some comments and say, step number one is to create an empty array with a pre-provisioned size. Now, the reason that that's important is because PowerShell has some helper mechanisms in it that will allow you to append items to an array. But what's not really obvious from the outset is that the array is actually being copied to a new array with a larger size. And that's what allows PowerShell to append an item to an array, even though the array is technically full. So that can create pretty significant performance issues. You're not going to see it in small scripts that are maybe managing 100 or 1,000 objects inside of an array. But if you're dealing with arrays of hundreds of thousands or millions of items, things like that, that can certainly have a pretty big impact. Even though memory is very fast as far as hardware goes, it does take a pretty significant amount of overhead to allocate new memory and copy memory to new memory and things like that. So we want to basically pre-provision or pre-allocate memory of a certain size, which is pretty easy to do in .NET. Then we want to fill the array with some randomized data, and these are going to be bytes, right? So when we're dealing with files on the file system, we're dealing with basically a massive array of bytes. You could have a 1 byte file or even a 0 byte file for that matter. But the smallest file that has any kind of content in it is going to be a single byte. And a byte is any value from 0 to 255. So there's 256 possible values for each byte in the file. That's the definition of a byte. So we want to basically generate some randomized data in the form of bytes and go ahead and just fill that entire array, however large it is. If it's a kilobyte, if it's 10 kilobytes, if it's a gigabyte, whatever that array size is that we pre-provision, we just want to fill the entire thing with some randomized bytes. And then the third thing that we want to do is to write the entire array to the file system. And that's pretty much it fundamentally. Now, there are some potential issues that you'll run into. As you may know, PowerShell is built on the .NET framework, and the .NET framework has the concept of a GC, a garbage collection system. And so .NET kind of cleans up memory for you automatically. And it's not always 100% perfect at doing that. And so you can run into memory leaks where applications will start to use up a lot of memory. And if you have a memory constrained system, like for example, I was dealing with a cloud virtual machine running on the Amazon EC2 Elastic Compute Cloud service that had, 2 virtual CPUs provisioned and like 1 to 2 gigabytes of RAM, depending on how much I was provisioning at the time. And when I was trying to develop this script, I was actually running into situations where PowerShell would just die. The process would get killed off because the system ran out of memory. And even though I was pretty well under the limits, I think I was provisioning arrays with like maybe anywhere from 5 to 700 megabytes in size. Even though I was doing that iteratively, the garbage collection system in .NET was not able to keep up. So we want to make sure that we're kind of forcing the garbage collection system to keep up by continuously calling the garbage collection mechanism in .NET. And you can do that pretty easily by referencing the system.gc class in the .NET framework. And then there is a method here called collect that takes no parameters. You can actually pass in optional parameters. There are some method overloads available, but the most basic form of the collect function here is to just take in no parameters. So that'll basically just force the garbage collection mechanism in the .NET Core framework to clean up memory that is no longer being referenced by your PowerShell script. All right, so what we're going to do is basically wrap this entire thing in a function here. And I kind of want to show you the PowerShell way of doing things, and then I want to show you some of the performance issues that you may run into when you use the PowerShell way of doing things, and then basically show you how you can plug into the .NET framework and improve performance pretty significantly. So I'm just going to create a function called createFile. So this is just going to create kind of a randomized file of a particular size. So I'll add in my typical commandlet binding and then add in a parameter here. And so we'll say int, and we'll just say size. And we'll set that to parameter mandatory equals true. So we want to force the user or caller of this createFile function to pass in a size. And I'll just call this new Trevor file, just to use a correct verb here so that PowerShell doesn't complain about the verb that I'm using. All right, so inside of the body of this function, we're going to be in the end block here technically because we're not going to declare the begin process end blocks in PowerShell. But the first thing that we typically would want to do is to just create an empty array. And so I'll just call this array data as a variable name to reference it by, and I can just create an empty array, right? And if I were to take this and hit F8 to declare that variable, I could look at the length of that array, and it's currently 0 items in size, right? So if I add in a few items here, like a few integer values, and take a look at the length of that array again, you can see now it's got 5 items inside of it here. Now, what I can do with arrays in PowerShell is I can say data plus equals, and then I can add an additional item on the right-hand side of that operator. So if I just run data plus equals 6, well, if I look at the length of the array, now it is 6 elements long. And so behind the scenes, what's actually happening is that the array is being copied into a new array with a larger size, and that's what allows PowerShell to append new items to the end of an existing array. But again, this has pretty serious performance implications. So if I was to try to add a whole bunch of items to an array, so let's go ahead and empty out this array. So it's 0 items, and then we'll just do something really simple like 1 to maybe 5,000. So that's the range operator, so we can just kind of create a range of items as integers. And then we'll say for each, we'll say data plus equals, and then PS item. So we're going to take 1 to 5,000, we're going to pass it into a for each loop, and just add 5,000 items to that array. Now, you can see that that ran just fine, and if I look at the length, I have 5,000 items. And you might be like, well, that's pretty fast, right? Well, why not just use this mechanism? Well, for handling hundreds or thousands of items, you're probably not going to have a severe performance impact. But if you say maybe 1 to 1 megabyte, how long is that going to take? So let's try to run that. Let me hit F8 to run, and you can see it's starting to hang here already. So 1 megabyte is like 1 million approximately bytes in size. And so we're going from 1 to 1 million, and we're appending each item to the array. And now we're starting to see a pretty significant performance impact when we're doing memory copies on the back end, and we're constantly allocating new memory, right? So this is a pretty significant performance degradation, and we don't want to do that. Now, what .NET has, let me fire up a new Firefox session right over here. What .NET has is a mechanism that allows us to create an array of a particular size. So if we search for system array in .NET right here, and we take a look at I think it's constructors. Where are the constructors? So we're in the array class, and let's search for constructors here. So there's an initialize function. Somewhere there is an array specific size here. And I didn't actually look into this before I started recording this, so I don't know exactly where this is, but somewhere there is a function to create an array with a specific size. And essentially what we can do is just declare that up front. Now in PowerShell, what that looks like is we can specify a data type. So let's just Control-C that. What we can do is specify a data type like byte, right? So byte is system.byte is a type in the .NET framework here that represents an individual byte, and then we can put square brackets after it to indicate that it's an array. And then we can call the new function on it, which will call the constructor for it. And if we do that without specifying any input arguments here, or specifying the parentheses, which would ultimately call the function, you can see that we can pass in an integer, which is going to be the size of the array. And you can do that for other types too. So if we did like a string new as an array, you can see we have an integer as a input argument that we can use to pre-provision an array of a particular size in memory. And so that way we can manipulate that array without having to reallocate the array in memory. And that cuts down on the number of new memory allocations that are occurring. It cuts down on the copy operations occurring because we can go to a specific point in memory and simply change a value without having to allocate new memory to the application. So we can do this for pretty much any type here. And so what I want to do is I want to say data is going to be a new system.byte array, and then I'm going to specify a size of 1 megabyte. So this will pre-allocate 1 megabyte of memory space so that we can manipulate it. Now, this is an array just like any other array in PowerShell, so I can go in and index into that array. And so it's going to, by default, put in zeros. So if I try to get like the last element of the array, it's going to be 0. If I try to get the second last element of the array, it's also going to be 0, because when we allocate, the default value of the byte type is simply a 0. Now, if we want to put in some randomized memory so that we can kind of bypass any compression mechanisms, maybe the OS is trying to do some kind of memory compression for us, and it says, oh, hey, you've got 1 megabyte of all zeros. So I can just have a value 0 and then some kind of multiplier and say, hey, this person has or this application has 1 megabyte of zeros in complete succession. There could be a pointer to the memory address for the starting point of that allocation, and then simply compress all that memory. Theoretically, I don't know if it's doing that or not, and I'm not really sure if there's a way to detect if it's doing that or not, but we want to kind of bypass that possibility. So we want to put some kind of randomized data into this pre-provisioned 1 megabyte array so that we can bypass any kind of mechanism like that, or at least make it much harder for it to do. So what we can do is actually build on a class in PowerShell called system.random. And so normally in PowerShell, you might say get random and then say minimum item is going to be 0. The maximum can be 255. And so every time that I run this, it'll give me a value from 0 to 255. And so I could use that X number of times, like 1 megabyte number of times, in order to populate my entire array, right? Well, unfortunately, just like we saw with the array copying that's happening, the getRandom function can also be kind of slow. So if we, let's say, do 1 to 500 kilobytes and say for each get random, and we'll just assign the result to data 2, for example. And I'm just writing some ad hoc code for now. I'm obviously not actually writing an entire function here, but you can see as soon as I run that, we're starting to hang here because we're having some issues with performance, right? Now, it's not necessarily to the same extent where we're having lots of memory copies happening behind the scenes, but as far as generating random data goes, that is a pretty slow operation for only 500 kilobytes of data, which is really not that much. So if we run measure command, so we're just going to wrap this entire command here inside of measure command so that we can see how fast or slow it's actually running. This will allow us to kind of see how long it's taking for that to occur. So it took a few seconds earlier. Let's go ahead and just run it again. And it looks like for 500 kilobytes of data, it is taking 5.7 seconds of time. And again, 500 kilobytes is not a lot of data, right? Just in general terms, video files are hundreds or of megabytes or gigabytes in size, right? A lot of the videos that I record are maybe 5 to 10 gigabytes in size. So 500 kilobytes really is not that much data. So if we wanted to generate, let's say 1 megabyte of data, it's going to take probably about twice as long. So a megabyte of data, which again is not that much data, it's going to take maybe somewhere around 12 seconds or 11 to 12 seconds. And that just is not acceptable performance because I want to be able to kind of exercise my system memory. I've got 64 gigabytes of system memory on this workstation here that I'm currently using. And I would like to be able to, kind of stress test this memory, fill it up, test how performance of various applications looks like when memory gets full on the operating system and things of that nature. So I don't want to be working in 500 kilobyte or 1 megabyte increments. I'm dealing with much larger data sizes. I want to be able to pre-provision, let's say a gigabyte of memory. And just like that, we have a gigabyte of memory allocated, right, in one operation rather than constantly having to reallocate it. So there is a class in .NET called the system.random class, which PowerShell has access to. It's kind of part of the .NET base class library, or BCL, that allows us to do things with randomized data using a random number generator, or RNG. And there is a function here that's very helpful called next bytes. And this function, next bytes, specifically populates a buffer that has been pre-provisioned. So the parameter that you pass into it is a byte array, which is the buffer that next bytes will fill with the set of random numbers that we want. So what we can do is simply go to the system.random class and then call this next bytes function here, and that's going to populate our array with randomized data. And we're going to see how much faster it is to do it with this mechanism rather than using something like PowerShell's built-in get random command. And if you're wondering why I'm doing all this, the situation that I wanted to kind of test was I was spinning up a cloud server in the Amazon EC2 service. And if you spin up a Linux server running on EC2, it's not really doing anything by default, right? There's not really any kind of workload running. I'd have to, build some kind of web server or build some kind of application that does some kind of randomized data processing, maybe that uses network connectivity, or maybe that uses disk connectivity or exercises the memory or something of that nature. And in this particular case, I was testing the file system performance using the Amazon Elastic Block Store service. So with your EC2 instance, you actually have what's called an EBS network attached volume as the root operating system drive mounted to that Linux system. And so by default, if you look at the metrics for that EBS volume in the CloudWatch service, there's automatic metrics that get gathered from EBS volumes in CloudWatch. It's basically just completely idle. And so I wanted to kind of generate some randomized, interesting data so that I could have a chart that showed kind of some level of story that I could tell with the chart rather than just having a straight line across the bottom saying 0 IOPS being used, 0 kilobytes of read and write throughput being used. I wanted there to be some kind of work happening in the background just to show that the EBS volume was actually being used and to be able to see how much of the EBS capacity was actually being consumed. So that's kind of what led to me putting this simple script together. All right, so as we can see, using the getRandom function is just slow for generating data. And I think actually getRandom might have a count on there as well. Yeah, it has a count. So let's really quickly, if you're saying, well, just use the count, let's see if that's any faster. So I'll go ahead and remove the for each because we don't need that. And then I'll change the count to 500 kilobytes. And let's just try and run that really quick. And so that was actually pretty fast, to be honest with you. So let's do a measure command on that just so we have some kind of comparison here. And so that takes 311 milliseconds. So that's actually pretty fast, honestly. If we run it a few more times, yeah, anywhere from 250 to 350 milliseconds on average. So that is actually surprisingly fast, but we're going to use the system.random class here. So I'll create a new random data generator by calling system.random and then call the new function on it. That'll just call the default constructor on it. And then, I don't know why I have two measure commands here. I think I just forgot that I already had one. And then what I'm going to do is use the random number generator to call the next bytes function. And I'm going to pass in the data buffer that we pre-provisioned right up here. So let's go ahead and select all this and run it. And it looks like that's actually pretty much on par with the get random command. That one actually took 160 milliseconds. That's surprisingly fast right there. And so now that we've kind of warmed it up, it actually seems like maybe that's actually quite a bit faster than get random. So it's about twice as fast as get random. And remember, this is a 1 gigabyte array of memory. Previously, for 500 kilobytes of data using a for each loop, we were seeing like 5.7 seconds of time to generate just 500 kilobytes of data. But now we're up to a gigabyte of data that we're generating in 161 milliseconds. So that's pretty freaking fast. So this is kind of the mechanism that I want to use here. But we want to parameterize this. So we're going to take this size input parameter here to our function, and we're going to pass it into the array provisioning right here. And then in PowerShell, typically you don't have to do this, but there is a command called remove variable, and this will basically just destroy a variable reference. And in theory, it should free up memory, but it may not actually happen until garbage collection occurs. And so I'm going to say I want to delete the data variable and the random variable, and I'm going to get rid of this measure command right here because we don't really need that anymore. And so every time that we call this function, we're going to provision the data variable, we're going to provision the random class, the RNG, we're going to populate the array here, and that returns void, so I don't need to nullify the result there. And it's going to delete these two variables that get created as part of the function. So now we have a function that generates a random array. And I did want to show you as well, now that we've got this huge array, this 1 gig array, if I go to, let's say, -1, which is the last element in the array, that's byte 209. If I go to the second one before that, it's 219. If I go to the one before that, it's 171. And so I can grab any kind of scope here. So if I said -40 to -30, these are all just kind of random bytes that are being generated by the random number generator. So that's just helping us to validate that the randomized data is actually good. And it's not just zeros anymore, right? So the OS, if it tried to compress my memory at all, would have issues doing so. All right, so we've got that. And now the last thing that we want to do is actually to write to the file system. So before we delete the variables, we do need to write the data to the file system. And so you could use set content and say -path. And then I typically like to create a variable called something like file path. And then I'll call this 0.bin. And then we'll pass in new GUID.GUID. And so what this is going to do, if I just run this part right here, is it's just going to generate a GUID file name with a .bin file extension at the end. So this uses .NET string formatting to basically pass in the GUID to this string, and it just appends .bin to the end of it. And then for the file path, we'll say pass in the $file path variable, and the value that we want to write to the file is going to be the data variable. And then we can say, I think as byte stream, or that may only be supported for certain parameter sets. So let's check that out really quick. Set content docs. And let's see, as byte stream. So set content path value as byte stream. It should allow me to do that. So let's try just forcing it anyway and see what happens. Oh, and I didn't declare this variable here. I just ran the code after it. So let's go ahead and run that. And so it's taking a little bit of time here to write that data to the file system. So several seconds at least here, not terribly fast. And I do have an NVMe SSD drive that's capable of writing about 1.4 gigabytes sustained per second. It's the WD Blue SN5000 4 terabyte model. So generally speaking, I should be able to write content pretty quickly, but set content just really is not a fast command. As we've seen with PowerShell commands, they're not always the fastest. They're definitely fast for developing scripts, but they're not necessarily fast for actual execution on the system. They're not necessarily resource efficient, I would say. So we want to kind of skip over doing that, and we want to use the .NET System IO file class. And you don't even have to instantiate this class. This is actually a static class. So the methods available on this class are just callable without instantiating a file instance. And there are a lot of helper methods on here. And there is a bunch of writer methods down here. So what we can say is write all bytes, like this right here. And there are a couple of method overloads here, or at least one method overload. But the most basic form is just taking a file path and a byte array. So just like we used system.random next bytes method to populate the array with some randomized data, we are going to pass in that same array, and then the write all bytes method is going to write that data to the specified file path. So that's a really simple and high performance mechanism to write data to the file system here. And it looks like this is hung. So I'm just going to go ahead and open up the task manager here and see if I can find which PowerShell process. I'm guessing it's this one right here that's taking up 21 gigs of memory. And we'll kill that. And then we'll go ahead and just reload our window here to reset the PowerShell extension. And so now we're, instead of using set content, we're going to use system.io.file and then say write all bytes. We're going to pass in the file path, and we're going to pass in our data variable right up here that contains our array of the specified size. And there's no cleanup that we have to do here because the write all bytes function just kind of takes care of opening the file handle, writing the data, closing the file handle, and moving on. It's a synchronous file operation, even though there are asynchronous versions of that available if you want to use those. And so that's pretty much it. So now what we can do down here, I'll just clean up these notes here. Now what we can do is say while true, basically just do these operations. And after every operation we do, we want to do a GC collect just to clean up memory. On my local system, it's probably not going to be an issue, but if you're running on a limited memory environment, it definitely could be an issue. And you did actually see my PowerShell instance was taking up 21 gigs of RAM locally. So maybe if I was dealing with larger data sets, maybe eventually I could run into an issue on my local system. But for now, I'm just going to call new Trevor file -size. And then I'm going to say size is going to be, let's start out with something relatively small, like 50 megabytes in size. And I'll go ahead and let me switch over to a different drive here. So I'll go into the F drive and create a directory called data-youtube, and then cd into that directory. And now we'll go ahead and run this entire script right here. And we want to kind of see how long this takes to actually run. So I'm going to say measure command on each iteration of this. And we'll say, give me the total, how about seconds that it takes to run. Actually, I'll do milliseconds. I kind of prefer that. A little extra bit of precision there as a whole number. And I'll just cast it to an integer because I don't care about any fractions of a millisecond. So we'll go ahead and run this and see how it works. All right, I don't know why I have a breakpoint there, so I'll go ahead and remove that. Let's rerun the script right here. And it looks like we are having a little bit of an issue here. So create a new file, total measure command, total milliseconds. I think I might need to actually wrap this in parentheses as well. Let me try that. Okay, it looks like that's not working either. So let's see what's going on here. So new Trevor file, size, data. Let's just say write host, creating array. And then we'll say write host filling array, and then we'll say writing to file system, writing array to file system, and let's see if that helps us at all. Okay, so we're still getting 0 as a result here. So let me just run this command really quickly. 67, 60. That sounds about right. Let's just do an ls to make sure the files are actually getting created. Okay, so they're not getting created. Let's go ahead and pass in the path here to make sure they're getting created in the right location. So we'll go ahead and do that. And we'll redefine our function here. And we'll go ahead and run this again. And for some reason, it's not giving me the result. Do I have the, oh, I have a typo in my, I had a typo in my property there. That's the downside to using a dynamic system here. Okay, so 569, 443, 757. And if we do a get child item, there you go. You can see we're creating all these 50 megabyte files, right? So what we can do is, let's just say comment out the write hosts because we don't need those for debugging right at the moment. And so now I'll just run this script and you can see this is a magnetic drive. This is not a solid state drive. So the performance is going to be a lot lower on this. So as you can see, we're anywhere from 500 to 1,000 milliseconds to write 50 megabytes of data, right? And so this is a pretty high performance way of accomplishing this. If I wanted to write larger files, all I need to do is to change the file size right here and say, hey, give me a 1 gigabyte file instead. We'll just go ahead and run that entire script again. And so now we can see how long it takes to write 1 gigabyte. And again, it's going to be slower because I'm now on a magnetic drive, but you can see it takes 6.3 seconds. And if you do, let's see, 1 gigabyte divided by 6 seconds, or 1 gigabyte divided by, 6 seconds divided by megabytes, 1 megabyte, that's about 170 megabytes per second, which sounds a little bit high for that drive, maybe something more like 146 megabytes per second. It is actually kind of a fast magnetic drive, surprisingly, but that's about the performance that we are getting there. So anyways, this is a much faster way of filling an array and then writing it to a file system, especially if you're using solid state storage. I don't want to chew up the write operations on my solid state drive, so I'm going to avoid doing that here. But again, if you're on a cloud server that's got maybe a local NVMe drive, or if you're using network attached things like EBS storage on your systems, then this can provide a really great mechanism to write data faster. And now that the cache on the drive is apparently filling up, we're starting to see somewhat more realistic write times here. So if we look at maybe 11.3 gigabytes divided by, 1 gigabyte divided by 11.3 seconds, divided by 1 megabyte, that's about 90 megs per second. So that's much more realistic for that magnetic drive once the DRAM cache that's on board that drive has been filled up. But again, you can kind of stress test memory out this way. You could use concepts like PowerShell run spaces or PowerShell background jobs in order to spin up more instances of this if you want to multi-thread things and start really chewing up memory. But I did want to show you that if we take a look at the process down here, so I'm assuming it's this one with PID 13308. Let's look at the PID. Yeah, it's PID 13308. You can see that this process is using about a gigabyte of memory. It's obviously using a little bit extra because PowerShell, the runtime always uses a little bit of extra memory to run, but it's not chewing up like 21 gigs of memory or something like that because we are continuously calling the garbage collection mechanism here, and we're just doing things a lot more efficiently inside of our script here. So, if we were to bump this down to something like maybe, 50 megabytes, again, something much smaller, and if we continue to rerun this, eventually we should actually see the memory come way down. So now we're down to using 320 megs of memory instead of a gig of memory. So by calling the garbage collection mechanism manually on a regular basis, that helps cut down on memory utilization, and on low memory instances, it can help you to cut down on the potential for the PowerShell process itself to actually get killed, even if you're well under the what you think is the memory limit, because PowerShell is just hanging on to all that extra memory. So, if you wanted to change this to something else like maybe, let's say 5 gigabytes, most of the time is going to be spent writing to the file system, but actually we can't do that here. So we have a maximum size of an int32. So we could say int32 and then max, I think. Let's put that in parentheses. Just say int32 max value. And it is complaining here. What's going on? You might have to do int32 max value -1. See if that works. No. Array dimensions. Let's try just -1 kilobyte. See if that works. I know I've run into this issue before where I've hit the max and I just wasn't able to create more than that. But yeah, so it looks like that'll work. So we're going to do whatever the maximum size of an integer is. Let's do in a different session here, int32 max value divided by 1 gigabyte. So that's like basically a 2 gigabyte file there. That's the maximum size of a 32-bit integer using this mechanism. And so now if we look at PowerShell, again, it's probably going to be taking up about 2 gigabytes of memory. Yeah, so like 2.3 gigabytes of memory right there. And again, you could use PowerShell run spaces or PowerShell background jobs to spin up additional threads, additional PowerShell processes in order to use up more memory on your system. But as you can see, we're currently consuming about 20 gigs of memory, and periodically when the garbage collection system runs, you can actually see these dips happening on a regular basis where garbage collection runs, it cleans up the data there, and then immediately a new array is re-provisioned to fill up that space, and then it writes it to the file system. So anyways, I just wanted to talk about this mechanism to kind of randomly generate data that's a little bit more interesting using a simple PowerShell script. Thanks again for watching. Leave a comment down below, leave a like on the video. Really helps out the channel a lot. Thanks to all the new subscribers that have been joining the channel as well. Again, I apologize that I've not been able to bring out content quite as often as I'd like to, but I try to do what I can. Thanks again, and we'll see you in the next video. Take care.